So we're looking for the absolute extrema on this interval from -4 to -2. And our function is x plus 2 to the 2/3. So first we want to find the critical numbers. So we're going to calculate the derivative. We'll bring the power down, leave the inside alone, take 1 away from the power, and chain by multiplying by the derivative of the inside. So we have, if we simplify this, 2 over 3 and x plus 2 to the 1/3 power. So our critical numbers are going to be where the derivative is equal to 0 or undefined. And because there's no variable in the numerator here, this function is never equal to 0. So we're going to get no critical numbers from the derivative equaling 0. But we do have a variable in the denominator. So if I set that factor equal to 0, I get -2 as a critical number. So I want to test my critical numbers as well as my endpoints. So my endpoint of -4, my critical number of -2, that also happens to be an endpoint. And I'm going to test that in the original function. We've got f of -4 is -4 plus 2 to the 2/3 power. That's -2 to the 2/3 power. The 2/3 power means the cube root of -2 squared. So that's the cube root of 4. And then we'll do f of -2. That's -2 plus 2 to the 2/3 power. That's 0 to the 2/3 power, which is 0. And so you can see that the highest will be the max and the lowest will be the min. So we have an absolute extrema, absolute max at -4 cube root of 4, and absolute min at -2, 0. Okay, we want to find the absolute extrema on the interval from -1 to 1 for the function f of x equals x to the 4th minus 3x squared plus 4. So first we need to find the critical numbers. We're going to calculate the derivative, and we'll use the power rule to get 4x cubed minus 6x. And then we want to find where this derivative is equal to 0. So I'll set the function equal to 0. I can solve this by factoring. There's a greatest common factor of 2x. If I factor that out, I'll be left with 2x squared minus 3. And I'll set each factor equal to 0 and solve. So if I divide by 2, I get x equals 0. Over here I would add 3 to get 2x squared equals 3. Divide by 2, and x squared equals 3 over 2. I'll square root both sides. and get x equals plus or minus square root of 3 over 2. So then I want to look and see if any of these critical numbers are on the interval. So I'm going to get my calculator to find out what the approximation is for square root of 3 over 2. I know 0 is in the interval. And by the way, so when you find critical numbers, you're looking for when the derivative is equal to 0 or undefined. Since our derivative is a polynomial, it's not going to be undefined for any value. So we've got all the critical numbers. But now I'm just checking to see if these critical numbers are in the interval. So this is 1.22, which is outside of the interval that we're looking at. We're looking at the interval from -1 to 1. And then negative square root of 3 over 2 will be -2.2, which is also outside the interval. So we're only going to be looking at the critical numbers in the interval as well as the endpoints. And we're going to test those critical numbers in the original function. So we'll look at -1, 0, and 1 in the function f of x. So that's -1 to the 4th minus 3 times -1 squared plus 4. So we have +1 minus 3 plus 4. That's 2. 0 to the 4th minus 3 times 0 squared plus 4 is 4. And 1 to the 4th minus 3 times 1 squared plus 4 will be 1 minus 3 plus 4, and that's 2. So the highest will be your max. We're going to have a max at 0, 4. The lowest, we have 2 lowest values. Those will be our mins. So we have absolute max at 0, 4, and absolute min at both of these points, -1, 2, and 1, 2. So we'll calculate the derivative and get 4x cubed minus 4x. Set that function equal to 0. And I have a greatest common factor of 4x. When I factor that out, I get 4x times x squared minus 1. X squared minus 1 is a difference of squares, so that factors more. X plus 1, x minus 1. And I can set each one of these factors equal to 0. This gives me x equals 0, x equals -1, and x equals +1. And the only value that's on the interval is x equals 1. -1 is outside our interval of 0 to infinity, and because we don't have a bracket on 0, 0 is also outside of the interval. So then I can substitute into the function to get y equals 1 squared minus 2 times 1 squared minus 3. That's 1 minus 2 minus 3. And we have 1 minus 5, which is -4. Now the theorem, the extreme value theorem, only guarantees that we have an absolute max and an absolute min if we have a continuous function on a closed interval. We do have a continuous function, but our interval is not a closed interval, so we're not guaranteed to have an absolute max and an absolute min. So our procedure that we were using, where you test the endpoints and the critical numbers, doesn't really apply here. So what I'm going to do is take a look at our graph of this function so I can decide if our function has an absolute max or a min at this one critical number that we have. So I'll type in our function. And take a look at the graph. Let me make sure I type that in correctly. Okay, so now we see the graph. I'm going to take a screenshot of that graph so we can write on it. So remember that we're only looking at the interval from 0 to infinity, so we're only looking at this piece of the graph. And looking at that piece of the graph, I can see that this point right here would be the absolute minimum, the lowest y value on the whole graph. And that point is 1, -4. We do not have a max on this interval since this piece of the graph goes on forever. And so there is no highest y value. So we have an absolute min of 1, -4.